So I'm going to work the problems from the third and last part of the practice final. All of the problems that I'm going to be working are dealing with quadratics. So let's solve x squared equals 20. Well, this looks like a problem that would be easiest to solve using the square root principle. If x squared is 20, then x is plus or minus the square root of 20. Now we need to look for perfect square factors in 20. Well, 20 is 4 times 5, so I can write this as x equals plus or minus the square root of 4 times the square root of 5. So x equals plus or minus 2 radical 5. Before I write my conclusion, though, I want to check and make sure this answer is correct. So what happens if I square plus or minus 2 radical 5? Well, whether I square a positive or a negative number, I get a positive result. 2 squared is 4, the square root of 5 squared is 5, and 4 times 5 is indeed 20. So my solutions check. So I can go ahead and write my conclusion. The solutions are negative 2 radical 5 and 2 radical 5. Here's another problem I can use the square root principle to solve. So if the square of x plus 5 is 36, then x plus 5 equals plus or minus the square root of 36. So x plus 5 equals plus or minus 6. So x equals negative 5 plus 6, or x equals negative 5 minus 6, which means x equals 1 or x equals negative 11. But I want to check this before I write my conclusion. So if x equals 1, then x plus 5 quantity squared equals 1 plus 5 quantity squared, which is 6 squared, which is 36. That checks. And if x equals negative 11, then x plus 5 quantity squared equals negative 11 plus 5 quantity squared. That's the square of negative 6, which is also 36. So that checks as well. So the solutions are negative 11 and 1. Now let's consider the equation x squared plus 3x minus 5 equals 0. What's the discriminant? Well, we're being asked about b squared minus 4ac, the radicand from the quadratic formula. In this case, that's 3 squared minus 4 times 1 times negative 5, which is 9 plus 20, which is 29. Well, what does the discriminant tell us about the equation? Since the discriminant is positive, I know that there are 2 real number solutions. So the equation has 2 real number solutions. And in fact, I know that the solutions are irrational since 29 is not a perfect square. Now let's solve negative 2x squared plus 4x equals 3. Well, whether I solve this by factoring or using the quadratic formula, I want to rewrite the equation so that I have 0 on one side of the equal sign. Since I prefer to work with a positive leading coefficient, I'm going to move all of the terms to the right. So that gives me 0 equals positive 2x squared minus 4x plus 3. If I were going to factor, I'd need to find integer factors of 6, that's 2 times 3, that add to negative 4. There are no such integers, so I'm going to have to use the quadratic formula. The quadratic formula tells me that x equals the opposite of b, so that's the opposite of negative 4, plus or minus the square root of b squared, so that's the square of negative 4, minus 4 times a, which is 2, times c, which is 3. All over 2 times a, that's 2 times 2. So this is 4 plus or minus the square root of 16 minus 24 all over 4. So this is 4 plus or minus the square root of negative 8 over 4. Since the discriminant is negative, I know that this equation has no real number solutions. The graph of f of x equals x squared plus 4x plus 3 is shown in figure 1. What's the domain of this quadratic function? So here I see a parabola opening upwards, and the arrows at the end indicate that the parabola goes on forever, up and to the right and up and to the left. When I'm looking for domain, I'm looking at my input values or my x values. Since this keeps going off to the right and off to the left, I'm picking up all real numbers. So the domain, if I write that in interval notation, is negative infinity to infinity. What about the range? Well, this is a little bit trickier. Now we're looking for our output values, so our y values. When we look at our graph, we see that this parabola has a lowest point. We don't have any y values below negative 1. The y values do continue to go upwards though, so we do get all of the positive y values. In interval notation, we would write negative 1 included, so I use a square bracket, to infinity. Consider the equation y equals the opposite of x squared plus 9x minus 20. This parabola opens down because a is negative. In this case, a is negative 1. The axis of symmetry is, well, I can use my formula to figure out what the axis of symmetry is. X is going to have to be the opposite of b over 2a. In this case, that's negative 9 over 2 times negative 1, which is 9/2. So the axis of symmetry is x equals 9/2, or I can write that as x equals 4.5. What about the vertex? Well, we know the x-coordinate of the vertex is 9/2, or 4.5. We can go ahead and find the y-coordinate by substituting x equals 9/2 into our equation. So if x is 9/2, y is the opposite of 9/2 squared plus 9 times 9/2 minus 20. So this is the opposite of 81/4 plus 81/2 minus 20. Now getting a common denominator, in this case that's 4, we have negative 81/4 plus 162/4 minus 80/4. Adding those all up, we get 1/4. So the vertex is 4.5 1/4. What about the horizontal intercepts? Well, to find the horizontal intercepts, I need to let y be 0. So if y equals 0, then we have 0 equals the opposite of x squared plus 9x minus 20. Now I think I want to factor this, but it's hard for me to factor when my leading coefficient is negative. I'm going to go ahead and move all of those terms from the right-hand side to the left-hand side, so I'll change all the signs. Positive x squared minus 9x plus 20 equals 0. Now it's a little bit easier for me to see that this factors as x minus 4 times the quantity x minus 5 equals 0. So x is either 4 or x is 5, which tells me the horizontal intercepts are 4, 0 and 5, 0. What about the vertical intercept? Well, this is actually the easiest question here. The vertical intercept has an x-coordinate of 0. When I substitute 0 in for x, y is going to be negative 20. Now we are asked to graph y equals x squared minus 8x plus 16. I think I want to start by thinking about the horizontal intercepts. So if I want to find the horizontal intercepts, I need to let y equal 0. And if y equals 0, then we have 0 equals x squared minus 8x plus 16. I can factor that right-hand side as the quantity x minus 4 times the quantity x minus 4. Well, this tells me x equals 4. So I only have one horizontal intercept. When we only have one horizontal intercept, the horizontal intercept is also the vertex of the parabola. So the horizontal intercept and vertex is 4, 0. So before we start thinking about more points, I want to note that it was easy to factor that right-hand side, so I could actually take my quadratic equation, y equals x squared minus 8x plus 16, and rewrite this as y equals x minus 4 quantity squared. That's going to make it easier for me to find some more points on the graph, which I need to do since at this point I only have one. The horizontal intercept and vertex are the same point. So I've got my vertex of 4, 0. Another easy point to find is the vertical intercept, which in this case is 0, 16. Well, knowing that I need to plot the points 4, 0 and 0, 16, I think I'm going to put my x-axis close to the bottom of the grid and my y-axis close to the left of the grid. Now I need to think about scale. Well, I think I can scale the x-axis just by ones. Since I need to plot the point 0, 16, I'm going to choose a scale of 2 on the y-axis. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So I've got the point 4, 0. I've got the point 0, 16. Since my axis is symmetry, x equals 4, I can use symmetry to find another point with a y-coordinate of 16 that's going to have to be 4 units to the right of the axis of symmetry. That's going to be the point 8, 16. Well, let's find a few more points. What happens if x is 5? Well, using my simpler to work with form of the equation, y is going to be 5 minus 4 squared, which is 1 squared, which is 1. So I've got the point 5, 1. Using symmetry, I also have the point 3, 1. What happens if x is 6? Well, y is going to be 6 minus 4 squared, that's 2 squared, or 4. So I have the point 6, 4. Using symmetry, I also have the point 2, 4. What happens if x is 7? Well, y is 7 minus 4 squared, that's 3 squared, or 9. So I have the point 7, 9. And by symmetry, I also have the point 1, 9. Now what happens if x is 9? Well, then I have 9 minus 4 squared, that's 5 squared, which is 25, which is just off my grid. So I'm going to use the points that I have here to sketch the parabola. And our parabola looks something like this. Now let's graph y equals x squared minus 4x plus 5. Well, thinking about the x-intercepts again, I would need to let y be 0. So if y equals 0, then we have 0 equals x squared minus 4x plus 5. Now I can't factor that right-hand side because there aren't integer factors of positive 5 that add to negative 4. So I'm going to use the quadratic formula. So the quadratic formula tells me that x equals the opposite of b, that's the opposite of negative 4, plus or minus the square root of b squared, so that's the square of negative 4, minus 4 times a, which is 1, times c, which is 5, all over 2a, so that's 2 times 1. So simplifying, I have 4 plus or minus the square root of 16 minus 20 over 2. So that's 4 plus or minus the square root of negative 4 over 2. Since the discriminant is negative, this tells me that there are no x-intercepts. Well, since I don't have the x-intercepts, let's think about the axis of symmetry and the vertex. Well, x is going to be minus b over 2a. So that's the opposite of negative 4 over 2 times 1. And that is positive 2. So my axis of symmetry is x equals 2, and know that my x-coordinate of my vertex is 2. So the vertex has an x-coordinate of 2. So if x is 2, then y is 2 squared minus 4 times 2. That's 4 minus 8, which is negative 4. And negative 4 plus 5 is 1. So the vertex is the point 2, 1. So working with my vertex as the point 2, 1, I know that there are no x-intercepts, so that means this parabola is going to have to open upwards, which makes sense because my leading coefficient is positive. Well, let's think about some more points on this graph. The vertical intercept's easy to find. That's 0, 5. And using symmetry, I need another point 2 units to the right of the axis of symmetry with the same y-coordinate of 5. So there's the point 4, 5. Well, what happens when x is 1? If x is 1, then y is 1 squared minus 4 times 1. That's 1 minus 4, which is negative 3. Negative 3 plus 5 is 2. So I have the point 1, 2. By symmetry, I also have the point 3, 2. Well, what happens when x is 5? Well, if x is 5, then y is 5 squared, 25, minus 4 times 5. 25 minus 20 is 5. 5 plus 5 is 10. My grid only goes up to 9, so that point is off the grid. So I'm going to sketch the parabola with the 5 points that I've found. So the parabola looks something like this. Now we have an application. Ethan throws an orange up in the air. Its distance in feet from the ground, t seconds after it is thrown, is given by d equals negative 16t squared plus 32t plus 3. What is the maximum height obtained by the orange, and when does the orange reach this height? Well, let's look at our equation for a second. We have a quadratic equation with a negative leading coefficient. So if I think about the graph, I'm going to have the graph of a parabola opening downwards. So the highest point on the parabola is going to be the vertex. So if I'm looking for the maximum height obtained by the orange, I'm interested in the vertex of this parabola. So the t-coordinate of the vertex I can find by using the formula. T equals opposite b over 2a. So that's opposite 32 over 2 times negative 16. That is positive 1. And if t equals positive 1, then d is negative 16 times 1 squared plus 32 times 1 plus 3. That's negative 16 plus 32 plus 3. That's 16 plus 3, which is 19. So it looks like the maximum height obtained by the orange is 19 feet. Let's go ahead and write our conclusion. The maximum height obtained by the orange is 19 feet. The orange reaches this height one second after Ethan throws it. Well, thinking about this Ethan problem again, when is the orange going to hit the ground? Well, d in this problem is defined to be the distance from the ground. We're looking for when does the orange hit the ground, so when does the orange have a distance of 0 from the ground? So we're thinking about d equaling 0. So if d is 0, then we have 0 equals negative 16 t squared plus 32t plus 3. The right-hand right-hand side looks a little bit too complicated to even think about factoring, so I'm just going to use the quadratic formula. So t is going to be the opposite of b, that's the opposite of 32, plus or minus the square root of b squared, that's 32 squared, minus 4 times a, which is negative 16, times c, which is 3, all over 2 times a, so 2 times negative 16. Now I think I'm going to get out my calculator to figure out what the radicand is. So I have 32 squared minus 4 times negative 16 times 3. 1216. That doesn't look like a perfect square, but I'm going to check to be sure. The square root of 1216, well, it's not a perfect square. So my radicand is 1216. So t is negative 32 plus or minus the square root of 1216 over negative 32. Now I want to find out when the orange hits the ground, so I want to know approximately what these two values are. So I'm going to pull out the calculator again and figure out the two values of t, approximately. So starting with, in parentheses, negative 32 plus the square root of 1216 divided by negative 32, I get this funny number. I need to remember this is scientific notation. This means about negative 0.0897. What about the other value of t? Well, pulling out the calculator again. So in parentheses, negative 32 minus the square root of 1216, all divided by negative 32. And for this one, I get about 2.09. T in this problem represents the amount of time in seconds since Ethan threw the orange. So t is approximately negative 0.0897, doesn't even make any sense in this application. So I'm going to work with t is approximately 2.09. And I'm going to pull out my calculator one more time to make sure that this actually fits the problem. So if t is about 2.09, what's d going to be? Well, d is negative 16 times t squared, so times 2.09 squared, plus 32 times 2.09 plus 3. And I get a number fairly close to 0. Remember, this is scientific notation, so this is about negative 0.0096. I expected some rounding error because I rounded the value of t to 2 decimal places. So let's write our conclusion. The orange hits the ground about 2.09 seconds after Ethan throws it. That's the end of our practice final. You want to make sure that you go back and practice lots of problems before your final, especially the ones that you had difficulties with on this practice final. Good luck on your final.
1, 2, 3, 4.